This is Dr. S. Mohan Lakshmi, Professor and Head, Department of ECE from Rohini College of Engineering and Technology. In this lecture, we are going to see about the communication and networking aspects. So, the first we'll see about the IoT access technology. So, we have different access technologies, and in this lecture, we'll see about IEEE 802.15.4. So on completion, the student will be able to define what is IEEE 802.15.4, and they'll be able to describe the layers of this particular uh, access technology, and they'll be able to explain the topology and security associated with it. So coming to this continuous lecture series of this IoT access technologies, we are going to see the following things. That is, in this lecture we see about 802.15.4. In the next lecture we'll see about 802.15.4 and G and the E 1.15E, as well as we'll see about the LoRaWAN. So coming to the first one, which is IEEE 802.15.4, it is a wireless access technology which is very familiar for low cost and low data rate devices that are powered or run on batteries. So it is commonly found in the following type of deployments: home and building automation, automotive networks, industrial wireless sensor networks, interactive toys and remote controls. And this focus on MAC reliability, that is medium access control reliability, unbounded latency, and susceptibility to interference and multipath fading. The reliability and latency degraded because of CSMA, that is, you would have heard about in the networks, which is collision sense multiple access and avoidance algorithm. Whereas the interference and multipath fading occur in this particular technology because it lacks a frequency hopping technique. That is, from one channel to the next channel, there will be a hopping. So this has the basic layer, which is a physical layer. This standard supports an extensive number of physical options that range from 2.4 gigahertz to certain sub-6 gigahertz frequencies in ISM bands. These standards is based on direct sequence spread spectrum, which is a modulation technique in which a signal is intentionally spread in the frequency domain, resulting in greater bandwidth. So here we have various transmission options, which is a 2.4 gigahertz with 16 channels and a data rate of 250 kbps, 915 megahertz 10 channels with a data rate of 440 kbps, 868 megahertz one channel with a data rate of 20 kbps. So only the 2.4 gigahertz band operates worldwide. So this is quite familiar at the international level, global level. So you can see here, this is the physical format which is available for the IEEE 802.15.4. So where you can see there is 6 byte for the front end, which is actually have the synchronization header, then physical header, and you will have almost 128 bytes of PSDU, that is PHY service data unit. So coming to the synchronization header, it has two components, which is preamble, which is a 32-bit or 4 byte for parallel construction pattern that identifies the start of the frame and is used to synchronize the data transmission. There is a second one, which is the start of frame delimiter fields. So this will inform the receiver that frame content start immediately after this byte. So any particular data is sent, there should be something to indicate that this is the start bit, or this is the start of the thing, or from the next frame you will get the byte, something like that. And the physical header, that will tell you about the frame length value. So it will let the receiver know how much total data to expect in the PSDU. So PSDU is the data field or payload. So the maximum size is 127 bytes. So here the next layer is a MAC layer. So MAC layer performs the following tasks. It manages access to the physical channel by defining how devices in the same area will share the frequencies allocated. And it also look into the scheduling and routing of data frames which are coordinated. And it will also look into a network beckoning for devices which acts as coordinators. So the certain new devices can be used as beacons to join in this particular network. PAN association and disassociation by device and device security, and there will be a link communication between two MAC entities, so which will be reliable. And this is the MAC format. So this gives you almost the physical frame already we have seen, and this physical frame, that is PSDU. So that 128 bytes is given, it is split up like this. So which means that you will be having a frame control sequence number, then you will be having the distribution PAN number, then other is identifier, destination address, source address, then PAN identifier, frame payload, frame check sequence, FRC. So here MAC frames are specified, which is data frame, which handles all transfers of data. Then beacon frame, which is in the transmission of beacons from a PAN coordinator. Acknowledgement frame, which will confirm the successful reception of a frame. And you also will have a command frame, so which will be responsible for all the control communication between devices. So the entire MAC frame is broken down into MAC header, payload, and footer fields. So the MAC header field will have the frame control, this will have the sequence number, it will have the addressing field. So something like it will specify, addressing field will specify the source and destination identifier as well as the source and destination address itself. And similarly, the sequence number will tell you the sequence identifier for the particular frame. And frame control will tell you what is the frame type, what is the addressing mode, and other control flags. The second, the MAC payload field varies by individual frame type, and it is maximum 127 bytes, and also defines how a 16-bit short address is assigned to the devices. Then finally, you will have a MAC footer, which is FCS, that is frame check sequence, which is a calculation based on the data in the frame that is used by the receiving side to confirm the integrity of the data. So coming to the next aspect, so we have seen two layers. One is physical layer, the other one is the MAC layer of this particular access technology. And we have seen what is the format for the respective two layers. And next we will talk about the topology. So what type of topologies are involved in this type of access technology? So mesh networks, mesh topology, star, peer-to-peer. So mesh networks tie together many nodes. These allow nodes that would be out of range if trying to communicate directly to intermediary nodes to transfer communication. So whereas this 802.15.4 PAN should be set up with a unique ID. So all the nodes in the same network, you should use the same PAN ID. So coming to this topology again, here you will be having a minimum of one FFD which will act as a PAN coordinator, and this is required to deliver the services that allow other devices to associate and form a cell or a PAN. A single PAN coordinator is identified with PAN ID, say example PAN ID 1. So a coordinator will have one particular ID which is identified as PAN ID 1. So FFT devices can communicate with any other devices, whereas RFT devices can communicate only with the FFT devices. So coming to the security aspect, so this particular technology uses advanced encryption standard AES with a 128-bit key length as a base encryption algorithm, which secures the data as well as validate the data that is sent. So validation is accomplished by a message integrity code, that is MIC, which is calculated from the entire frame using the same AES key that is used for encryption. So AES is a block cipher method, which means it operates on fixed size blocks of data. So this is actually related to the security. So you can see MAC header, MAC payload, MAC footer, everything over here. And here the first one which is indicated with a 1, that will be enabled, or the security enabled bit in frame control is set to 1. Whereas in the second one, the auxiliary security header field is added to the MAC frame. So coming again to the features of this security features, it slightly and consumes some of the payload. Using the security enabled field in the frame control portion of this particular technology header is the first step to enabling AES encryption. So this field is a single bit that is set to 1 for security. So once this is particular bit is set, then the security is ensured. Once this bit is set, a field called the auxiliary security header is created after the source address field by stealing some bytes from the payload field. So these are the possible assessment questions. So you will be able to know what is IEEE 802.15.4. You can able to describe what are the physical and MAC layers of this particular access technology, and you will be able to explain the topology and security associated with this access technology. Thank you.